Hello everyone, I am Ahmed Magdi from Kashif team, here to represent the landmine detection project. Actually, when we talk about landmines, we are talking about the 800 people that die monthly. 50,000 to 25,000 people are maimed or killed by landmine-related injuries. Approximately 80% of these casualties are civilians, like you and me. On the other hand, a large number of unreachable resources exist underneath. Egypt, for example, has 5 billion barrels of oil, 13 trillion cubic feet of natural gas, besides the large area of cultivatable area are rendered useless. Usually, a metal detector is used to solve this problem. But the metal detector, besides its low accuracy that gives only one correct alarm for every 1,000 alarm, it only can detect metal. So the anti-personnel mines that are made of plastic cannot be detected. Such a problem must have been approached by many solutions. These solutions use men, dogs, rats, vehicles. All these solutions are exposed to danger because they are directly contact to the Earth. After heavy research, we found that the GPR is the most effective method to detect the buried objects. In June 2011, a World Conference said that the future solution should eliminate the Earth contact. From here we started. From here we decided to solve this problem. We made a GPR that can fly. The GPR system is simply transmit signals to the ground and analyze the reflected signals to tell us what exactly underneath the ground. And from here, Ahmed Hassan will continue.
So here comes our project, the product GB Air. What we have done here is that we put together our requirements and we've thought of a way to produce a viable solution, an effective product that when it gets into the market satisfies the customer's need. So what we have done here is that we built this quadcopter. It's a rotor, an unmanned air vehicle operated wirelessly via an application on the base station. This is made specifically for this purpose, detecting landmines. Okay, the innovation here is in the radar component. Usually, the GBR component is operated by man. It is held in hand and is in complete contact with the earth. Okay. So what we have accomplished here is that we re-architectured the system of the radar so that it is capable to be put on the air vehicle. So it is suitable for air use. Okay, we have also patented our design of antennas here. You can see the transmit and receive antennas. These antennas are also suitable for penetration from the air. So we can penetrate two mediums, the air and the earth. The application on the base station is currently for the desktop, but we will continue developing it so it can be put on portable devices like mobile applications. Okay, so the innovation here in comparison with the traditional GBR system is that we have created a lightweight solution. It is very much faster, and of course it is the algorithm we've made in the base station application is soil specific. So when you scan ice, you have a different algorithm that is processing in comparison when you scan the sand, an example. Okay. So we have successfully hit the prototype milestone back in June. We have reviewed our prototype in our campus in front of the dean and the vice president of the university, our supervisor, Dr. Atif Abulaz, and the governor of Menifee was there. Regarding our technology roadmap, we are currently in the tuning and testing stage. We will launch our product in the second half of 2015. An interesting feature here is the sniffing capability. This will enable us to tell if the landmine contains TNT. The TNT material is still operational or not. So landmines, over time, they lose sensitivity. So they might not be detonated when using other solutions like detonating landmines. And from here, my friend Ahmed Abdelmajid will continue.
Hello. In order for us to get into the market, we must have a competition advantage over the other competitors. What we have done is that we patent our idea and our design to make a barrier for the new entries and to protect our intellectual property. We are expecting that our product will be introduced to the market by the next year in Egypt. As we mentioned before, we have 4.8 billion landmines in Egypt, 4.8 petrol in Egypt cubic feet, and 13.4 cubic feet of natural gas in the Western Desert. And these areas are out of use because they are expected areas to be affected by land mines. Right? We believe that we have a born global product that will have no geographical barriers. 110 million landmines are there in the worldwide, and 67 countries are afflicted by landmines. This will widen our target market in the next step. Our next step, as we see, that we expect our product within the next 2 years is to be able to detect subsurfaces like silver, gold, and many subsurfaces, which will give us a new opportunity into the market and a new competitive advantage. With our product, customers will be able to survey and investigate areas that they have never been able to reach before. That's accomplished tasks in a time frame which is not compatible with the traditional alternative solutions. Our product is safe for the operators that they are involved in the mining actions. The investment in GPR technology can easily be realized by eliminating the human element. Putting aside the cost of the mining, what value can be compared against the human life? Our vision is to seek a world with no landmines. We seek a land where you can put your feet without fear. We can go far than the international agreements. And finally, we can create peace. Thanks, everybody.
Right. Is it on? Does it work? Yeah. Okay. My question, if you go back to the slide about your competition, you had a slide about the different technologies and no, much farther back, way earlier.
The other techniques?
The other techniques, yes.
The table.
Way back,
First
back.
Which
Way,
table?
it was a huge spreadsheet. There we go. That's
Yeah.
the one. What I'm curious about is the, for instance, if you take the rats that are doing landmine detection, they're of course very complex, but they reproduce themselves. You don't have to worry about that. The cost, rats don't cost very much. They're reasonably okay, not too fast. Okay, you think you're faster than them, right? Is that, am I reading that correctly? Why, and yes, they're safe for everything but the rats, of course. Why environmental, why do you say that you're better than the rats?
The rats.
Yeah, than the rats, the hero rats.
Rats.
Yeah, but I happen to be a donor to the rat
Okay,
project,
okay.
That's why I know about
First
the
of
rats.
all, rats could explode the anti-personnel landmines.
Yeah.
Because their sensitivity are lost over the years. So anything will pass over these landmines will explode, even with half a kilogram. So it's not safe and it's not active to use rats. Besides, it's not controllable. You cannot tell the rat just to scan this area and he can do it specifically. It's not that smart to do that. You cannot trust his mind. You don't know it's rats after all, it's rats. After all, it's not that accurate.
In addition, rats can explode the anti-personnel landmines, okay? But what about the anti-tank landmines? And what about when the sensitivity is lost over the years and the TNT is no longer is there? The landmine could explode. That 80% of the landmines are UXOs. That's the
Unexploded ordnance.
yeah.
Yes, the unexploded ordnance. And besides the large areas, rats cannot extend to large areas and walk all these areas.
Okay, so you're saying you're faster, you cover larger areas,
And the accuracy.
and you're more accurate.
Sure, we're more accurate. We can tell what exactly underneath the ground. Not only mines, not only if it's anti-personnel landmines or rocks or any other landmine. It just tells what exactly under the ground.
Okay.
I'll ask something completely different. So tell me about the electromagnetic detection. How far down into the ground can you detect things?
Actually, it's under developing. So in the next year, we are working on penetrating for more than 10 meters under the ground. And there is no landmine exist under this distance under the ground. So we can check the deepest landmines. And this is a prototype. We can check for landmines under 3 meters right now.
3 meters?
For this prototype.
Okay. And did you have a built-in mechanism for controlling the vehicle so that you know for sure that you're scanning the whole area? So it operates in that way. You send it out. And how does it deal with mountains and things going up and down?
It has an altitude.
It's an automated air vehicle. So we have an autopilot program. From your base station, you can control if you want an altitude hold position, if you want to scan the surface in, let's say, 1 meter above the earth. So any hills or downs, they cannot affect this air vehicle. So it has it has a stability, high stability, and it stands against the weather condition. Okay, and regarding the penetration depth, so like I said, it's all about the precision algorithm. So when you talk about ice, of course, the results will be different when you talk about the desert. So in ice, you can penetrate, let's say, 200 meters. But in the desert, you can reach 10 meters. And of course, we are in the early stages, so we will have another development. So we will re-architecture the radar system, the antenna component. This solution does not contain any amplifications. We can provide amplifiers. We can increase the depth. Of course, this will require tuning. So yes, we are considering every possibility.
And forests are not a problem if you have to hover fairly high above the ground because there's a forest in between?
Yeah, no problem for the air vehicle, but like I said, the radar will require another processing algorithm for the forest environment.
Well, to be honest, this is a challenge for us as we are going to be for a global market. So in Egypt, it's a sandy desert. Maybe in other countries, it's not. It's not. So as it's an advantage, as a challenge, it's an advantage for the GPR technology that we can modify its hardware for 40% of the hardware and 20% of the software to be to can act in another environment. So as it's a challenge, it's advantage for the GPR technology that we can adapt it for another environment.
Yeah. One purpose of this competition is to identify a pain, right? And I think that you've done that in a fairly good way. This is very literally a pain. And also that you have a couple of new application areas, looking for minerals and water and stuff like that. But these, my question is a bit related to yours, Christina. These clients that you've identified, they're quite demanding, right? Could you say something about their requirements for this kind of technology? I mean, rats is one thing, but the technology used in this area, I could imagine that they have some some pretty tough requirements on that, and also that this kind of service then is conducted in pretty harsh environments. And you said that, yeah, that's not a problem, but how? I mean, what do you do with your product to actually mitigate that? Would be my question.
So first of all, we're targeting the petroleum companies, so we're talking oil, okay? There's a lot of money. And of course, they're willing to pay anything if you can get rid of these landmines so that they can dig and extract oil. Plus, in the technology roadmap, in our third version of the product, we are developing the swarming capability. Yes, the swarming capability right there, just before the version 2. So we will not just go into the field with one air vehicle, we will have a swarm, and this of course will require development in the persistent algorithm, but of course we can guarantee the utmost accuracy, and that's all they care about.
And how would it be resilient to these harsh environments? You're talking about ice and deserts and stuff like that?
Yes,
yeah.
that's the ultraviolet technology, and over the last 2 years, this became no challenge. Of course, processing power is increased day by day, and this is just a prototype. But of course, there are other solutions, there are other systems. We can simply integrate a powerful machine, and this will be no problem.
So is this a part of your invention, or is it part of integration of somebody else's?
Yep. This prototype is actually based on the open source project of Arduino. It's licensed under the LGBL. So we have modified the autopilot program to adapt this to our environment. But of course, we are currently expanding our team, so we'll have some real good developers, and we can build our own program.
Okay, thank you much.
Thank you.
Sorry. Thank you for the presentation. I'm still struggling to understand what the innovation is here, because I spent 8 years in the Swedish engineers in the army, clearing mines all around the world. So I had my fair share of mine detection. And GPR isn't anything new. GPR on helicopters has been used for checking out glaciers for 10 years. They have GPRs on drones in the States, in the Army, for EIDs. So, I mean, what's the actual innovation here? I don't get that.
Yes, we have said that for in GPR, the typical GPR and ours. What could you get it, please? Where is it? Then GPR over. Yes, this is it. We have said that there are, as you said, the typical GPR is found, it exists, but over a near vehicle to detect landmines over two services, the air and the underground. This is the innovation, to put a GPR over an air vehicle to detect landmines. This is not found yet. Last year in Croatia, there were a conference for landmine action, and they say that anybody who wants to make a solution for landmines, he has to put the GPR over, to be over the earth with no contact with the earth. So this is the innovation, to put it on an air vehicle that can transmit signals and penetrate the subsurface and come back with reflected signals, and you can process it. Okay. That's it. Thank you.
This is great. Big problem, undesirable solutions, etc. So great job. I too have some questions on clarifying in my own mind what it is that is your innovation. So I'm going to take a different tack. What is it that's in your patent? What did you choose to talk about that was your innovation? And where did you file your patent? In what country?
So regarding the patent, it's about the integration of the system. Okay, we are currently patenting the integration process that we've done. Okay, We've integrated the radar into our air vehicle in a way that was never done before. Okay, that's the idea.
Where is that in here? Is that the
Yep,
bottom set of
this is the
antenna?
radar component. Okay,
Okay.
it's tethered with the air vehicle system, and this is via protocoling and integration in the code, and of course about the design of the antenna. That's another patent. We like I said, we have re-architectured the whole system. So it is suitable for air use. We're not talking about getting your helicopter into the ground. No, it's in the air and it penetrates two mediums. Of course, the antennas, this is something new. It's a 3-layer antenna. I'm not going to talk about the specifics. We're currently pending for the patent, and we're filing it in the University of Manifia under the supervision of our advisor, Professor Atif. And
Will it be filed in Egypt or in the United States or
Yes.
in Europe or where?
well, I think Dr. Atif can clarify. It's currently it's pending. I don't know.
You have filed a provisional patent?
Yep.
And on last year, this year?
And it's after hitting the prototype milestone back in June. It was in mid-July.
Okay. And is every component required, or can you take your radar and antenna and put it on a different UAV airframe?
Yes, so this is a reference model. So of course, if any customer wants to integrate this into another air vehicle or into another component, we'll have to do some changes. But of course, that's for the business team or the marketing team to decide.
Okay. How high off the ground? You talked about how far into the ground you can penetrate, but
Yeah.
how high off the ground can you be right now?
Yeah, the air vehicle can go very high. Like, talking about the GBR, like I said, it's dependent on the soil. So when we are talking about the ice, you can be 2 meters high, and you can penetrate like 30 meters down. In the desert, you can be 3 meters high. You can penetrate 1 meter underneath.
Okay.
So it's dependent.
basically the height of a person.
Yep.
Um,
So excuse me, what was that? What?
I'm looking for a range, but it sounds to me like
Yeah,
in
yeah.
general,
Yeah.
about the height of a person.
We
There's no general case, actually. There's no general case. But this quadcopter is specifically made for this purpose. We can choose the altitude depending on the nature of the surface. If it's soil, whatever type of soil, it can perform a flight, suitable landing at very low altitudes to give us the accurate results about what's underneath the ground at any depth.
Okay. And then before I turn this over to my teammates, have you got an estimate on what this costs?
What?
How much?
The cost? About
Well, part
Three-
of what we have to hear is the
3,000. Okay,
economic
okay.
viability of what you're doing.
it's not more than $3,000.
3?
Not more than $3,000.
Okay. And then I have a safety and health question. Does that happen to dovetail with anything you guys are interested in? Your actual radar.
Yes.
It's a standard radar that you're using, standard GPR, so it's already been tested. This is a yes or no question.
Yes.
It's already been tested, so you
Yes.
know what the health characteristics
It's-
are of the electromagnetic radiation.
Yes. Most of the radars. Actually, we are all engineers. Group of communication and electronic engineers. We've been bending and testing this GPR since June 2011. And we are actually working on it to give better results. That's what we are working on.
So it's re-architecture, okay?
3D architecture GPR, not the typical GPR that people buy in the shops.
Oh, dear. No.
Okay, last question then. A bit more on the economics. I know you're engineers. This is a technology invention, but can you say something about the business model? Do you have any ideas on that?
Well, as we have said, our first market is in Egypt for the petroleum and gas companies, and as we have said, to that the global market, there are Libya, Afghanistan, Iraq, and another country that we can go to help them in this technology. They are still using metal detectors, as the detection market is likely dominated by metal detectors till now. So we have we can be the first mover in a lot of countries and a lot of markets. Yes.
And your envision it's a product selling type of business model.
Yes.
That's your idea. Okay. Okay.
Thank you very much.
Thank you very much.
Thank you very much.